We are jumping straight into something that makes you look down. I mean, way, way down, into one of the most incredible landmarks on Earth, the Grand Canyon. Right there in Arizona, just this massive, colorful masterpiece of rock and time.
That's it, exactly.
Yeah.
And today we're not just, admiring a giant hole in the ground. We're using the Grand Canyon like a history book. A time machine, really, that's carved right into the landscape.
Okay, so what's our mission then?
Our mission is to unpack how this enormous thing actually formed and why its scale is so important for understanding, well, the entire history of our planet.
And the timelines here are they're mind-boggling. The carving itself started around, what, 6 million years ago?
Around 6 million years ago, yeah. But the rocks that the river exposed, some of those go back nearly 2 billion years. It's like an open-air library of deep time.
So to even begin to understand that, we have to start with the sheer size of the place.
You have to. Let's try to put it in perspective. Yeah. The Grand Canyon is about 277 miles long. I mean, imagine getting in a car and driving for 5 hours straight. That's roughly how far it stretches.
And it's not just long, it's incredibly wide. In some spots, it's up to 18 miles across. That's wider than a lot of cities.
And the depth. That's what gets people. You're standing on the edge, the rim, and you're looking down over a mile to the Colorado River at the bottom.
It's just a stunning reminder of what nature can do. But how? How does a river carve a hole that big?
Well, the simple answer is a process called erosion. You can think of the water acting like a giant piece of sandpaper, just constantly wearing down the layers of rock.
But I feel like there's more to it. That alone doesn't seem like enough to explain something on this scale. The land itself has to cooperate, right?
Exactly. That's the crucial insight. We have to talk about something called tectonic uplift. The whole area, the Colorado Plateau, has been slowly lifting up for millions of years because of forces deep inside the Earth.
Okay, wait. So the river's digging down, but at the same time, the ground under it is being pushed up.
Precisely. And if the land lifts, the river's path gets steeper. A steeper path means the water flows faster. And faster water carries more sand and rocks, which gives it, way more cutting power.
Ah, so that combination, the uplift and the erosion, is the real engine that created the canyon.
That's the engine. And you can see the proof of this when you look at the top edges, what they call the rims.
Right, the North Rim and the South Rim. Most people visit the South Rim because it's easier to get to.
It is, but the North Rim tells a really interesting part of the story. It's actually a lot higher than the South Rim, sometimes by 1,000 feet.
And that's not just random.
Not at all. It's evidence of what geologists call differential uplift. The northern part of the plateau is just tilted up higher than the southern part.
And because it's so much higher, the North Rim is way cooler. It's a huge geographical difference. In the winter, it can get buried under feet of snow, and they have to close it down completely.
Yeah, and that extreme change in elevation is why the weather there can feel so fractured. You could be standing on the North Rim in a jacket, enjoying the cool air, while a mile below you, the inner canyon is just a blistering hot oven.
And the river is what connects all of it. It's really the irreplaceable primary cause for the whole thing.
It's a powerhouse, that river. And it's not just the water doing the work. The river is like a conveyor belt. It carries away millions of tons of mud, sand, pebbles every single day. Those particles are the real tools scraping away at the rock.
And the river itself is just enormous. It's about 1,450 miles long, and it starts way up in the Rocky Mountains.
It's life-giving water, too. As it carves the canyon, it's also providing essential water for people and wildlife all across these dry desert areas. It's crucial.
If you ever visit, you can actually travel on it by boat, right? Which gives you a totally different perspective from the bottom looking up.
Oh, absolutely. And even if you're standing on the rim, if it's quiet, you can often hear the roar of the water echoing all the way up from the bottom.
Okay, so let's shift from the power of the water to the power of time. Because the reason the canyon is so famous isn't just its size. It's what the size shows us, the rock layers.
Exactly. When you look at the canyon walls, you're looking at pages in a giant history book. You see these different bands of color reds, oranges, grays, greens. Each layer tells a different story about what this place used to be.
And that story starts at the very, very bottom, the oldest rocks down there near the river. What are they called?
The Vishnu schist. And those rocks are nearly 2 billion years old. To put that in perspective, that's before complex life even existed on Earth. These are some of the oldest exposed rocks on the planet.
2 billion years. I mean, how do you even wrap your head around that? What was the world like back then?
It was a primal world. Those rocks formed from intense heat and pressure deep in the Earth's crust during what's called the Precambrian era. But the truly mind-blowing thing is what happens right above those ancient rocks.
There's something missing.
That's right. It's like someone ripped a massive chunk of pages out of the book. It's famously called the Great Unconformity. You have rocks that are, say, 1.8 billion years old sitting directly underneath rocks that are 550 million years old.
So over 1 billion years of geological history is just gone.
This is gone. It's one of the great mysteries. Scientists think those layers were formed, but then were completely eroded away before the next layers were deposited on top. The canyon is famous for what it shows us, but also for this massive gap in time.
So if we climb out of that gap and we look at the younger, more colorful layers higher up, what do they tell us?
They tell a story of ancient seas, shifting deserts and swamps.
All right.
We can literally read the environment in the rock. For example, there's a thick, can-colored layer near the top called the Coconino Sandstone.
Okay.
Geologists know that layer was once a massive desert because the rock still has the patterns of ancient sand dunes in it.
That is incredible. A desert turned to stone. And I think there's another layer, the Hermit Shale, that shows a totally different environment.
Absolutely. The Hermit Shale, it's softer and redder, and it tells us the region was once a warm coastal swamp, a completely different, wetter climate.
Which brings us to fossils. If this land was a sea and a desert and a swamp, there must be evidence of the creatures that live there.
And there is. The canyon is full of them. We find tiny shells from sea creatures in the limestone, which confirms the ocean theory. We also find fossilized footprints of early reptiles walking across what was once that sandy desert.
And that has to be the ultimate aha moment for anyone visiting. Realizing that ocean creatures once lived where you're now standing, in a hot, dry desert, it just shows how drastically the planet has changed.
And speaking of drastic changes, let's talk about the climate inside the canyon right now, because the extremes are intense. We said the north rim can be snowy, but at the bottom, in the summer, temperatures regularly blast past 100 degrees Fahrenheit.
And the air is so dry, you have to drink a ton of water just to stay safe. And you have to watch out for sudden afternoon thunderstorms, too. They can cause dangerous flash floods in the side canyons with almost no warning.
Exactly. And because of these dramatic shifts in temperature and elevation, the canyon supports a huge variety of life, each adapted to its own little zone.
The plants are fascinating. At the top, near the rims, you're in this cool forest-like area with pine and oak trees, but as you hike down, it totally transforms.
You start to see the desert survivors, like cacti and tough shrubs. Take the yucca plant. Native peoples learned to use its fibers to make rope and baskets. Plants there have evolved incredible tricks, like super long roots to find water or waxy leaves to hold moisture in.
And where you have plants, you have animals. The canyon supports a huge variety of wildlife on all its different levels.
You find some amazing specialists. The bighorn sheep, for example, are perfectly built for climbing those steep, rocky cliffs. And flying above them, you might see a California condor. It's one of the largest birds in North America. They use the hot air rising from the canyon to just glide.
You might see mule deer, but visitors really need to remember it's a wild place. There are rattlesnakes and scorpions, so you have to be careful where you put your hands and feet.
And a lot of the animals are most active at night when it's cooler. So during the day, they're hiding from the heat, which can make the canyon feel quieter than it really is.
Okay, let's switch gears a bit. We've talked about 2 billion years of rock, but humans have only been in this landscape for a tiny, tiny fraction of that time.
It's true, but human history here is still very deep. Native American tribes like the Havasupai and the Hualapai have lived in the canyon for centuries. They still have communities there today, and for them, the Grand Canyon is a sacred place, deeply tied to their history.
And you can see physical proof of that history, can't you? These ancient structures called granaries.
Yes, these small stone storage rooms built right into the cliffs. They were used to keep food like corn and beans safe from animals and the weather.
So who were the first Europeans to see it?
That would be Spanish explorers back in 1540. And the funny thing is, they weren't looking for a canyon. They were searching for mythical cities of gold and just stumbled upon it.
And it took centuries after that before anyone really tried to explore the river at the bottom.
That didn't happen until 1869, with the famous expedition led by John Wesley Powell. He was a one-armed Civil War veteran and a professor, and he led a team down the dangerous, unknown rapids of the Colorado River in these little wooden boats.
I can't even imagine how dangerous that must have been. They were navigating completely uncharted water.
It was incredibly difficult. They lost boats, supplies. The crew faced starvation. But Powell was meticulous, and his team's survival meant they created the very first detailed maps and scientific reports of the canyon.
And those reports were huge, weren't they? They brought this hidden wonder to the public's attention and really paved the way for the tourism and preservation we see today.
And speaking of tourism, millions of people visit the Grand Canyon National Park every single year from all over the world.
Most of them, they walk the paved paths on the rim, take photos from the overlooks. But for the more adventurous,
You can ride mules down the trails, a tradition that goes way back. Or you can hike, but the park rangers always stress that it is extremely strenuous and needs a lot of planning and water. The rangers are essential there. They teach visitors about the delicate balance of the place.
and the fact that it's a national park is so important. The National Park Service works to protect it from construction and pollution.
Which brings us to visitor responsibility. The rules are there for a reason. Stay on the trails, carry out all of your trash, and they even limit noise from air traffic to keep it peaceful.
Right. Protecting it is a shared responsibility so that future students, maybe you listening, can visit and see what the Earth looked like long, long ago.
So at the end of the day, the Grand Canyon is so much more than just a pretty view. It's an active science lab. It shows us the power of water, the power of uplift, and it lays out 2 billion years of our planet's history, even with that big billion-year gap.
And here's a final thought for you to think about. Even with all this research, scientists still debate exactly when the Grand Canyon started to form. Was it 6 million years ago, or could it be much, much older? The great debate over its age means the Grand Canyon still holds secrets deep in its walls.
Keep exploring these incredible natural places. We'll see you next time.